with current cell technology PERC, we cannot reach a much higher efficiency. Of course, we see different technologies, manufacturers trying to use the PERC modules with back contact, having some improvements, but still the main category is P-types.
Okay, so it's time for our first guest from manufacturer side. With us is Marcin Jędrachowicz from Jinko Solar, main supplier with TOPCon models. Marcin, I hope you will share with us Jinko point of view of photovoltaic market, and the spotlight is on you.
Thank you, Mikołaj. Thank you for invitation. I'm glad to be there with you on your Menlo days. I can start with some short summary, as I just received the numbers for the last year, and it's found out that Menlo was our third, the biggest distribution company in Europe. So congratulations.
Thank you.
And actually, it's already third year when we are working together. We are together with Menlo from very beginning, when you establish your first sales, first distribution in Poland, and then develop more. So yeah, it's very nice to have a chance to summarize what we are doing now with Jinko Solar, what is our plan with current portfolio and future development.
Great. I hope our plans will go well. And what do you want to share with us today?
So I will say about our N-Type technology and the future of PV modules. So maybe the title is too big, because I will mostly focus where we are now, why we're doing what we are doing, and I think to run this presentation in the way how to explain somebody why Jinko. So if there's so many module manufacturers now on the market, so yes, and as an end customer can be really confused what to choose and why. So maybe try to help them and explain more why Jinko is quite good choice. So I start.
Feel free, sure.
So firstly, I would like to say a little bit about our current position. So Jinko was established in 2006, and now we already we already make a huge progress, now being the biggest manufacturer worldwide. After summary of the numbers last year, yes, we delivered the biggest volume of modules. We have the biggest production capacity. Of course, this only parameter is not everything, because in the current market situation, especially last year when the overcapacity was seen everywhere, it was not only about capacity, but about utilization rate. So how many of these megawatts you produce, you can produce, you really produce and deliver. In our case, as I remember, the numbers were really great. So almost 97% or something like that. We already use this capacity, produce, deliver. So demand for Jinko modules were very, very big. And I will explain later why. What is important to notice in this slide, so we delivered already 200 gigawatts. So if we calculate a worldwide production from the beginning of the industry, every 15 of module is Jinko. So it's something very nice to know that in worldwide, almost everywhere you can find our products. And it's currently it's not only Chinese manufacturers, because we have a manufacturer factories in China, in Malaysia, and also in the United States. So its management is around the world, and we can say now that we are like a worldwide corporation leading PV manufacturing, not only like a Chinese brand. So thinking about production capacity, so why I put this slide here, everybody can say now this was always a case when we can compare PV modules manufacturers in terms of production volume capacity. So even if you take the Bloomberg Tier 1 list, it is shown how many megawatts, gigawatts everybody can produce in the list. And now we can go deeper. So what is important, not only how many modules you produce, but also how many cells, wafers, ingots, so how integrated is your structure. Because in a current market, when we see some like a black swans every quarter with some challenges, breaking supply chains, and challenges is a good word because so we see how everything is changing. So now a company who have the whole supply chain inside the structure, we produce our wafers, we develop our technology, and then control all the process. So we are, say, one step ahead from all the others who need to buy it from the market, and they are dependent on the other suppliers, and in general also about quality, because of course sometimes it can even cost us more because we need to make a control and the investment of the whole process. This is our facilities, our company. Somebody can just pay and then take the products. But if we have it inside, we control all the production process, quality. We design all this, and we plan how it will be developed in future. That's why I will say much more about N-Type and the TOPCon, especially in the future of in this presentation, because what we want to say that it's a natural evolution of our products. Not something what we just chosen yesterday to switch to the new technology, but actually we already make the first world records, which is recorded as our achievement in the development in photovoltaic many years ago with N-Type P-type, so N-Type polycrystalline modules. So nobody produce it in the big scale to sell and commercialize, but we already make our research and make the first efficiency records in the N-Type polycrystalline modules. So it's showing how long is our thinking about the development of this technology.
So it's ancient history. And you said that you have factory in United States. So actually you are resistant for a situation which happens this year in the Red Sea, that if the one road to the Europe from China will be closed from any reasons, because last year we have Suez Canal was blocked. This year, because of war of attacks on Red Sea, the main road was closed as well. So if you have different direction which you can supply models, you are resistant to that situation. Am I understand you correctly?
That's right, but honestly speaking, a US factory is occupied with orders for a few years in advance. So in the end, we cannot use this capacity. It's a different market, different price, different products actually. You just highlight how important is geopolitical situation now to all markets and all procurement process. That's why companies like yours, who can take more responsibility on this process, are much appreciated by final investors who not always have the knowledge and possibilities to control all this process. So just coming back to presentation, in general, quality control and the planning in this production capacity integration, vertical integration is crucial here. This will happen even more. So for us, we just planning this gigafactory. We call it gigafactory, but in general, it will be 56 gigawatts of production of module production capacity under one roof, when we will produce wafer cells and modules in one place. So we all know how important is now this traceability of all products, of components, and how the knowledge of final investors grow last year. So now they know what to check, what to look at in the production in terms of quality control, about audits in the factories to be sure that quality is in the correct. So now having this one factory, they can be sure and check personally in one factory all the process together.
And so where it will be located? Where it will be located?
I'm not expert in Chinese geography, so that's
somewhere in China.
Yes,
okay.
Yes.
In the east, sure.
So I know this very close location by train to biggest ports in China. So this is all designed to be efficient in the production and easy to audit, but also to be very effective in terms of energy use and carbon footprint topics. So we expect to be a factory will be fully using the only green energy. So it's the idea. Sure. We'll see. Coming with the presentation, I can show you some awards we have. But of course, I'm smiling now because going online in LinkedIn, all the media, we see everybody is proud of awards they have. So now maybe a simple picture of the award is not enough to ensure that the quality is correct, because it's too easy to get. From the other hand, yeah, we have a history with that. So again, it's not about to be there with TopCon today and tomorrow change to other technology because something changed on the market and they switch and jump from one to the another. Our goal is to be there in the very long term. And also we see here, I mean, top performer from PVL and many other awards. So this is something what we are achieving every single year with all our products. And what I just checked preparing for this meeting with our technical team, what is very special, our latest TopCon N-Type products, Tiger Neo, they were checked by PVL, the NVGL, PVL, they make these tests, choosing one product from the market, not ordering from us, but choosing from the local market to be, let's say, to get the standard products what is available, and they check that our products pass all the tests in the best level compared to any others who put products to the test. So it was something unusual, and we can be proud of that, as we are proving in many different ways that simply TopCon modules are degrading less and they are more reliable, and we have proofs for that.
Can we have some access to that report to share it with our clients?
Yeah. So this is PVL is mostly recognized in the United States, but it's becoming popular also in Europe. We have also recently passed the 3 times reliability tests from TÜV Nord, if I'm not mistaken. It will be in the presentation later. So it is also something very nice, because normally they not put the modules in that high pressure, like a 3 times standard parameters, and now they did, and we passed it. So it's something what we can share as well. Yeah, so we know if you are a home owner, you want to have your modules on your roof with a warranty for 30 years. You have some doubts, right? 30 years, come on, it's a long time. But then this kind of tests, when they put it in the really high pressure in different parameters, testing it, it makes you a little more calm that its products not designed only to be minimum for the European standards, but to be designed for working 30 years. Yeah, I have Jinko modules on my own roof, so I'm in this team. And where we are now, so a global team, global leader in technological innovation. So why we are saying that? We have we have even more now, 2,027 people in research and development team. So it's like an army, like a university, Jinko University with development and all this research team. And it's translated to many patents and records. Now we see graphs showing 22-time world records, what we achieve with our different technology in time. We see every record with a higher efficiency. I see the first one is actually polycrystalline N-type. This is something what I mentioned before. So step by step, we just increase the efficiency, and with the newest technology, we are able to improve our products. And what is important, we use like around 7-8% of our revenue to research and development every year. And when the market standard is like 2-3, so it's a few times higher than the market standard. That's why we can guide the market, let's say lead the market with the new technology, and many smaller players just need to listen what's the other. The good example is we recently launched some news that our TopCon patent, we are selling it, let's say sharing it with other smaller manufacturers, so they are allowed to use it and produce using our patent. So we see that this works. We have our products better and better, but also we can make money and build our position sharing this patent.
When I look on this slide, it's not a real question. So when you reach the next record and 27% of efficiency?
Good question. So I think we already see different records all around on different technologies. So I mentioned now that we are promoting this N-Type TOPCon, where we are now with our development as natural evolution of current production lines of our research. Of course, everybody make a research. We too also have perovskite models on the heterojunction, on back contact. So there are different technologies. And one thing is about record in the laboratory, and other thing is about commercial big scale use, what we can finally buy and install. So I think for this real use, we will not have it in this year. But what I see now for TOPCon models, especially for this newest size in the rectangular cell size, the efficiency is growing really fast. As I will speak later about roadmap, but on the example of this product from the real life, I'm receiving replies from production management center in China when they are saying me about 600 watt products just in February, March this year, and the same product will be already 640 in the beginning of next year. So this speed of efficiency grow in this new rectangular cells is nice. We'll see.
Okay. So let's move on.
Okay, so this is technical slide. So talking in general, so we are always saying P-type, N-type, so it's good to just mention the difference, because we can categorize products by different filters. So first, what is the main polarization of the silicon cells? And this is exactly P-type, N-types. So we only describe by this what is the doping inside the silicon. If this creating the positive, let's say positive or negative in the cell. So in general, this is not explaining the other category of products. So we can have the P-type with back contact, or P-type heterojunction, or so in general there is so many technologies, but this is a different categorization, not the doping. So now we're saying first we choose N-type. So we dope this silicon with phosphorus, having this improvement. About advantages I will say just later, but we have we have N-type because this is something what give us longer life, less degradation, and many others. And then we have different types of N-type. So now is technology, and in terms of technology, we used to use N-type paired. It was one of many N-type ways how to build the cell and models. And now as a next step, we go to N-type TOPCon. So what is special in N-type TOPCon is additional ultra thin oxide layer. So even the name, like a tunnel oxide passivated contact. So this is TOPCon. And so here we are. Doping is a phosphor, and we have N-type. And as a technology, currently is a TOPCon.
Okay.
And why we choose that? And looking at the roadmap of the cell efficiency, let's say the historical efficiency, how all the world records continue grow, we see that for the few years since 2017 to 2020-21, the gap between N-type and P-type efficiency, modulus efficiency, was quite similar. So they all grow. But last 2 years, we see something like PERC technology is not allowing to have a more development, and with current cell technology PERC, we cannot reach a much higher efficiency. Of course, we see different technologies, manufacturers trying to use the PERC modules with back contact, having some improvements, but still the main category is P-type. So we have a doping with boron or gallium, but it's still something was not giving that great parameters like N-type doping. So that's why we are here with our N-type and TOPCon technology, having the targets with so high efficiency. It's now even 26.4% of cell. You already asked about 7, so we will have a higher, because we expect that in a few years we can achieve even 28.7, what is like a laboratory. Our research team, they think this is like a top what we can do with current TOPCon technology, but also we're thinking about next development. So This is the main reason to choose TOPCon now, changing from PERC, because in the real life, the most important parameter is efficiency. How much we can install on one roof, this depends on efficiency, how much power we fix in the one plate of the module, or how much we fit in the one container, and then how many construction we need to put the modules on the roof. So it's all about efficiency,
how much work we have to put into it.
Exactly, so how it's all about power density, which is, let's say, described by efficiency.
Yeah. But do you know maybe what's the gap between, because here you show us the efficiency of cell, but it's not the same as efficiency of the module. Because with the module you need to add the gap between cells, you need to add frame. What the gap between cell efficiency and module efficiency, more or less?
Yeah, so it's few percent, and in general now, let's say modules have 22.5 average efficiency. So you see, it's quite a big gap. So this is another challenge what we're trying to solve. And of course, this is different ways to do it. In general, we need to find the front surface as much effective space not as possible. So we are trying to make the bus bars as thin as possible. They are solutions with back contact. They are ways to make the overlaps of the cell, or making the gaps between the cells as small as possible. So there are few solutions, and actually this is what we are doing now, changing our product portfolio a little bit to the micro rectangular, where the gaps between cells are smaller, and I will show that.
Sure.
It's a good title, N-Type TOPCon, state of the art. Yeah, we are saying in that because let's say 2 years back, or even 1.5 years back. So we make our homework already with development, researching what is the easiest, what is the next step in a industry in general. Maybe not the easiest, but like a natural evolution. And we were already sure about our path with TOPCon technology, and it was SNEC 2 years ago, 1.5, as the biggest expo in China, when only few manufacturers together with us show, okay, TOPCon, we will produce it, it is our path. And all the others say, no, we have many problems with this technology, it's not that easy to implement. And just 1 year later, all from the top 20 manufacturers show it, and yes, okay, they have right, we will do it as well. So it's, of course, it's nice to say about that in the perspective that yes, we are right. That's also showing the confidence that we know what we are doing, and when we introduce some product, it's not the lottery, but we simply make our preparation, and now the product is ready, it's reliable, is enough prepared. So what is the future? Yes, we will continue with TOPCon next generations. We see from our technical department, they thinking about some tandem, perovskite, heterojunction cells, but we see how dynamic is the market. Every quarter, every half year, we have something new, and at least some small lifting. So for sure, we will need to make all these meetings and trainings.
Sure.
We will have our work to do it because the market is changing all the time.
And how long do you expect that TOPCon will be the leading technology? Like P-type PERC was leading technology since 2019 up to 2024. In 2025, I guess they lose the leader position. So it was 6 years. Previous technology was leading 6 years. Now TOPCon is the next leading technology, also thanks to Jinko. You hit the market with that, but how long? How long you expect that TOPCon will be leading technology?
Just a few months ago, our management was worried if we are able to sell any PERC, because we have still some capacity to produce. They don't want to just, close the factories and don't produce PERCs and only produce N-type. It just needs to be step by step. But it's doing so fast. So now, just a few weeks ago, we received the latest update asking if we can convince our customer who already signed the contract for PERC if they can change from N-Type, because changing all these production facilities and switching all to N-Type is faster than they can expect. This is a difficult question. So I don't know how fast it will go, but it's all about money. So if we have a more efficient product and our customer can make more money or save money on this, and the investment in new technology is, let's say, calculated in this, they will do it. But I don't know the dates.
Sure,
yeah.
sure. And if you have glass ball, looking on that slide, if you have glass ball, which technology will be the most competitive to TOPCon? Because you said there's a doping silicon, there is TOPCon, which adding additional layer of passivation layer. There is heterojunction, different type of production cells. There is back contact technologies, different way of connecting cells all together. So there are few factors, and connecting all the factors we have. If we multiply, there's all possible path. Mm-hmm. So, in your opinion, as a guy who is closest to the market as could be, and to the manufacturer, in your opinion, which technology will be successor of TOPCon?
Yes.
Because here you show transparent back contact, heterojunction back contact, integrated back contact, heterojunction modules as a parallelly developed with TOPCon. So, in your opinion, it's just an opinion, we play with glass ball.
Yeah, so in general, you ask about the real efficiency of the modules compared to efficiency of the cell in the laboratory. Mm-hmm. So having the back contact allowing us to make this front efficiency higher because we are hiding these bus bars back in the back. So it's something what we see like natural also next steps, because we have the N-Type, we have a TOPCon what is still work together, and now this back contact also can be used for TOPCon. But you know, I see the positive feedback also for heterojunctions and from technical teams from different investors. They think about it also in terms of lower degradation in long time. There are still some challenges of this technology, first in the commercialization in the big scale because it's more expensive, but also they are less resistant to some moisture. They have some more risk for hotspots. So they are, like scientists are saying about some challenges for this technology. They were able to find the solutions for these challenges, and the technology will be fully reliable. Then it's maybe something connected with TOPCon and heterojunction, but I have no idea.
Okay.
So, but speaking about what we have now, because it's also nice to show our guests about the current portfolio and how it's changed a little bit in this lifting. But now we have the cross-section of the TOPCon cell, and I would focus here about this ultra-thin silicon oxide layer. So it's very special to have it in the cell, because thanks to this we have the better carrier conductivity and better activity rate. So we are saying that the products can work in the low light performance, and also we have this better efficiency thanks to this layer. In general, N-type doping have the less impurities and better thickness uniformity. So in general, this is several benefits of the TOPCon and N-type, what is translated later to advantage. But first, portfolio. So this is portfolio what we already announced a long time ago. Is little changing. So what I'm showing here is a micro rectangular cell, so 182.3 per 183.5. So it's very small rectangular. It's almost square. That's why most of these products don't change even the size. So the size, weight, everything the same. We're increasing a little bit. We're trying to make these products more efficient and with better electrical parameters to every month, every quarter bring something better to the market. And here is the small products. Most of them you know, but they are two what's actually quite new. So a 66 cell product with a size of 2 meters 382 0.1134. So this is the new standard. So we can call it like a new standard on the PV market because it's many big manufacturers who agree. So this will be the new size. You can also you can think about your idea for what is inside, but we're trying to make it easier for the final investors, design teams, mounting structure manufacturers, everybody, just to fix in the same mounting size of the module, and we choose the cell size 182 per 210. So let's say this is the complex of this M10 with G12, something in between.
So the biggest manufacturers agreed to make with their models with the same exact size. No matter what investor which model they will choose, all of them will have exactly the same size, and you be part of that race to have best model in that particular site. Do I understand correctly?
That's exactly what is the conclusion. In general, I know there is several different cell sites and the cell design inside the module. That's why we will have different parameters for different module manufacturer in the same size of the frame.
Okay.
And it will be one of the most popular product in our new Gigafactory, so we're trying to make it in the big scale. And what is interesting, we are receiving more and more inquiries for very big utility scale customers, like 300 megawatts, 500 megawatts, and they put in the initial design a requirement, though this is the size they expect for all participants in the tender. So it's also giving us confidence that these technicians from investor side, they also see this beneficial in this size, and this is simply more efficient in the project design. So now about benefits. So we have low degradation. This is thanks to the LID and the lithium effects, what are minimized thanks to this N-type doping. Simply modules degrade less, and it's not even aggressive here. So our linear degradation mean minus 0.4% and first year 1%. So according to our technical team, this is like easy. And it could be more aggressive, but we're trying to keep market standards, so to be not aggressive, but be reliable and be in the safe side always to the investors, so they know that they are choosing Jinko not because they see the super aggressive numbers on the data sheets, but they know it's like they can be sure about the parameters what we are
to be
giving.
Nicely surprised.
Yeah, in this way, not an opposite. Bifacial factor. So this is something what I know 99% of the projects, utility projects in Poland, they are bifacial now. So now also this bifacial factor, what is explaining a percentage of the use of the reflected light. So if we let's say put the model and try to use the light the same density in both sides, then the bottom side is always a little bit worse, and this how worse is describing by this bifacial factor. So here we can expect like 80% of the front glass to be efficiency of the low bottom.
Sure.
I hope it was understandable. So it's better than the perk. Yeah. And what's very interesting, because in the years in the past, not everybody make the calculation in that deep level, thinking about the production after 10 years, but they mostly focus on the initial design, first year, how much we can improve in the first year and compare production. But now much more knowledge is on the market, and the technicians, experts, they analyze what's happening in the whole life in the production cycle. And now if we're having lower degradation, of course, is the first factor. And talking about lower temperature coefficient, it is something what is giving us the real numbers in the operating temperature, not only in the laboratory, in the STC, but normally the temperature is higher. Cells are having a high temperature, especially in these bigger cells when the temperature is extremely high in the big sun. So now having this temperature coefficients in lower is 0.29 compared to 35, what is like a market average currently for PERC and other technologies, is giving us simply 2% more energy gain only thanks to this factor. And what's also nice to mention, real operating temperature in N-type are lower than in P-type. And I was wondering why is real temperature different? And yesterday somebody explained me, if there is a sun, it can be used in two ways. First, you can have energy or have a heat. So if we use it more for energy, having bigger efficiency, we produce less heat. It's as simple as that. So we have more efficient modules, we have less temperature. So
efficiency factor. Ah, interesting. It's good to know.
You ask if we can have some tests results. So this is a 3 times reliability test from comparing EAC parameters, what we make with TÜV Nord. And it's impressive because normally all manufacturers are saying, yes, we are okay with EAC and showing how their modules degrade with these tests. They can't degrade more than 5%. If they don't, it's okay, you can use the models in Europe. But we make the 3 times harder tests, and we also don't degrade higher than 5%. So this is something what's opening eyes for final investor. Okay, so it's something designed to be stronger.
Okay.
And I talked before about this better activation rate. This is also here we see that it works better in the low light performance. It's something we can check with the pound files. So we have certified pound files. They are prepared with the tests of each parameters and making the design. You can check how they react in the low light performance. We see from the investor side, especially for Scandinavia or any places where the light is less intense, like than Spain, for example, then appreciate N-Type even more than the southern countries.
True.
So it's that. So just to summarize this view, improve energy generation, how we found it. So it's optimized temperature coefficient. We talk about this low real working temperature. Bifacial factor is higher. So if we use utility scale bifacial products, in general, we have more effect of bifaciality. These modules degrade less, so we don't have this or minimize a lot this LID and lighted effects. And we have very reliable product. I will show also here because it's not only reliable from other way around. We tested it in the much stronger parameters, and we found out that especially these smaller products, 54 cells, we can prove higher mechanical loads. So we just found out that it's possible, and it's important from final investors. I know there's a lot of mounting structures companies. They have some special, they own design, so they want to have modules more reliable and also save money on the mounting structure. So here is the product what we can be sure about higher loads, and especially now we have this difficult climate challenges, certainly hails on different winds, sky winds, and so having more reliable products for this residential design mostly is something what should be interesting for final investor.
Sure.
On top of that, we have higher warranty. I always say it's only marketing, because in the real warranty, this is the linear warranty. So even after 15 years of warranty or 25 for full black, if the product is not performing well according to linear warranty, which is for 30 years, this is our warranty claim. So in general, this is what investors should focus. What degradation we proving for these products, and real warranty is always for 30 years now for the N-Type. So just make to my customers happy, we also give this product warranty bigger. So it's 15 for the standard product, like a silver, and full black is 25 now.
It's product which is already available, or it's for the future one?
Yeah, there is. When we open any datasheet, we have the 5 or 6 range of the power. So the product is still the same. When the efficiency of cells is continuously growing, we're just launching the new power class. And it's so for us, it's still the same product. It's just a few power class. And actually, this silver 54 cells rectangular, it will be even in Q2 production. It's already 450. You have it ordered already.
Okay.
But the full black, I'm not sure when we reach 445. Maybe even this year. So we are very close to this level what we are already showing here.
I heard about 435 few days.
You know, from the production to the final roof in Europe, it's quite a long time.
2-3 months,
at least 3-4 months right now. So that's why we're showing now like a little higher power, but its production will be in February. You will receive it in May, and then your customer will install it in summer. So that's why we have this gap in time.
Yeah, sure.
That's all.
Marcin, thank you for your participation. Thank you for your time and interesting presentation.
Thank you, and I wish you a great year with our Menlo and all your partners.